Now we're going to look at quadratic inequalities. Solving quadratic inequalities are solved in a similar way to how quadratic equations are solved, but, if you'll notice the big but, there are actual sections on the number line that will work. So I've got steps here. Step 1 and step 2, always got to do this. Step 3 can vary. Change the inequality symbol to an equal sign and solve the resulting equation. This gets you back to something that you've already done. Step 2, graph the solutions that you found in step 1 on the number line. Use solid dots on the solutions to represent less than or equal to or greater than or equal to, or open dots on the solutions to represent less than or greater than. And step 1, step 2 should sound familiar because we did this very exact same thing when we were doing linear inequalities. Step 3, we also did this back with linear inequalities. Check each region by taking a test value out of that region and putting it back into the original inequality. You shade sections that make true statements. You do not shade sections that give false statements. So I'm going to do it this way first. Okay. This big or step 3, we'll look at the graph. We did not do this in the other part. So let's do this. Let me move this down. So I've got to change this to an equal sign. So let's see if I did. Well, excuse me, I moved everything over to one side and then I probably changed it to an equal sign. Hope so. Yay. Okay. So now we need to solve this. So I'm going to do it by factoring, and it looks like I need 2 and 4. So x plus 2, x plus 4. And solve these things. Remember, break these up, set them individually equal to 0. So I'd end up with x equals negative 2 or x equals negative 4. And we're going to plot those. So here's negative 4, here's negative 2. We put them on the number line, but now it says to graph the solutions, use solid dots on solutions to represent less than or equal to or greater than or equal to, and open dots for less than or greater than. So technically, once I've done this right here and I've found my answer, I've got to go back. And usually I go back to this one right here to help me decide. So I need an open dot at negative 4 and negative 2. Let me go snag that one. Whoa. Oh, so I have a big dot. So put that there. Let me put the other one right here. Guess I don't need the humongous dot, but that's okay. So I placed them at negative 4, negative 2. And now it says to check each region by taking the test value out of that region and put it back into the original inequality. So let me get my calculator. So I'm going to use negative 6. So negative 6 storing for x. Now I'm actually going to put it in this one because it's a little bit faster. I could put it in this one, but both of them will give me the same, decision that I have to make. So x squared plus 6x plus 8. So here's my question. Is 8 less than 0? If you say yes, okay, then we would have to shade that section, but hopefully you said no. 8 is not less than 0. So let's try this section. I'm going to put negative 3 in. Remember, we do not shade sections that do not work. So now I'm going to put negative 3 into the statement. So here I come back. Negative 1 is less than 0. And that's a true statement. So I need to shade in between negative 4 and negative 2. Let's see if it's going to let me. Ugh, don't want that. Shapes. I'm going to go from here to right here. Can I make it bigger? Cool. So I'm only shading between negative 4 and negative 2. Okay? but I need to go ahead and try this section. You always need to try the sections. So, well, shoot, I'm going to use 0, because if I use 0, I don't need my calculator. If I put 0 in, this term and this term will be 0. I end up with the statement 8 is less than 0, which is, nope, that does not work. So, my answer here would be, I need a parentheses, -4, comma, -2, in parentheses, because I'm supposed to write my answer in interval notation. So that would be that piece right there. So what I want to look at right now is step 3. It says go look at the graph. So I'm going to type in x squared plus 6x plus 8 into my calculator. Clear that off. X squared plus 6x plus 8. Ask it to graph. Okay. Now, looking at this graph, I want my values on this side to be negative, my y values to be negative. Well, guys, the only place where my y values are negative is where it's under right here, and that's between -4 and -2. These other values are over. Okay? So let's see what this says. Go look at the graph. Sections of the graph that are above the x-axis are where the y values are positive, and sections of the graph that are below the x-axis are where the y values are negative. So it says shade the graph appropriately. That will give you a true statement. So again, on this one, I want this side to be negative. The only place is between -2 and -4. Let's try this next one. So I guess if I did what I did earlier, I moved the 16 over. So let me do that. Okay. And now this is a difference of perfect squares. But before I go look at that, I need to first change it to an equation. I have x plus 4, x minus 4. Set them individually equal to 0. So we should have x equals -4, x equals 4. So let me get rid of that. So now, what kind of dots do I need? Hopefully you said solid, because this is greater than or equal to. So let me go snag my solid dot up here. We'll use it. Maybe I'll make it a little bit bigger. Ooh, oh well, that's okay. So let's put it at -4 and at 4. Okay. Let's go look at the graph, and then we'll check sections, and we'll see if we agree with what we've got. Let's go back to y equals, and this is why I have this one. We're going to put in x squared minus 16. Let's do minus 16 and delete that guy. Okay, let's graph. Okay. Now, I want this side. Think about this. This side has got to be greater than or equal to 0. For it to be greater than or equal to 0, it's going to have to be positive. Well, on my graph where it's positive, it looks like it's positive to this side of -4 and to this side of 4. Now, let's see. Let's try values. I'm going to type in -5. Or do I need to? Or can we do it in our head? Let's do it in our head. If I put -5 in, -5 squared would be 25. 25 minus 16 would be 9. Is 9 greater than or equal to 0? Hopefully you said yes. So let me go shade. So I get to shade from here this way. Make it big. Okay. Let's try 0. 0 is nice. If I put 0 in, is -16 greater than or equal to 0? Hopefully you said no, and which means I do no shading. Let's try this side. I'm going to use 6 this time. Be different, because it's on this side 4. If I put in 6, 6 squared is 36. 36 minus 16 is 20. Is 20 greater than or equal to 0? And hopefully you said yes. So I'm going to go get me another little arrow thingy, and I'll go from here this way. And make it bigger. So there's my shading. So let me tab over so we can write down interval notation. I'm coming in, so this is negative infinity. Negative, oh my goodness. I need to insert infinity. Oh, there it is. Yay. Comma to -4. And I need a bracket. And then you need a union. Oh goodness, I wonder if I've got a union symbol. I guess I'll use that one. It looks like a capital U, but just pretend it's union. So bracket 4, comma, and let me go get my infinity back with a parentheses. Yay. So that's how I can do it graphically and indicating my answer using interval notation. So you've got some problems you need to go do, and try it, both ways. You need to get comfortable. I mean, we've done step 3, this original step 3 before. But guys, this right here is fast if you go look at the graph. Okay? Thank you.